So, in chapter 11, our next topic is an important one, and it is groundwater. So, this looks like a picture of oil erupting out of the earth, but it's definitely not. It is groundwater. This picture was taken in the 1800s when the Midwest was really being settled and farming was being established. We know that the Midwest is prone to drought after huge events like the Dust Bowl. But what makes the Midwest a stable place for farming is because within the earth in the Midwest, there's a rock layer called the Ogallala Aquifer. And the Ogallala Aquifer is a really reliable source of groundwater. It's actually helped to stabilize farming in the Midwest and really enhance the quality of life for people who live there. When I'm talking about groundwater, I'm talking about any water that's found in the pores of soil and in fractures in bedrock. And so your first assignment has you look at groundwater and some of the important characteristics about what makes a layer that's useful for groundwater in the earth, whether it's bedrock or whether it's soil, and what makes a good rock layer. An aquifer is a rock layer that's really useful for groundwater extraction. And so this Ogallala Aquifer underlays the earth from North Dakota, pretty much south all the way to Texas. So it's really instrumental in the settling of the Midwest. You can find groundwater in a whole bunch of different places. You can find it in areas where there's been dissolution of the bedrock, like where there are caves. You can also find it in igneous and metamorphic rock layers where the bedrock, although it's crystalline, can be fractured. One of my jobs before I became an MCC faculty member was working in the water division of the U.S. Geological Survey in Raleigh, North Carolina. And in Asheville, North Carolina, there was this man who was trying to dig a well on his property. And the fracture system is pretty much how groundwater gets transmitted in the Blue Ridge Mountains of North Carolina. So he was kind of trying to find a fracture, but wasn't really taking a whole lot of advice, and he just figured that he would just keep drilling and drilling and drilling, and eventually he would hit a fracture. This man had a well dug on his property that was 1,000 feet deep, and he just got kind of unlucky, like he didn't map out the fracture systems, and so he really just kind of dug down into more and more crystalline rock that had no groundwater. It was a little sad, but not terrible. I guess he survived. Groundwater is also found a lot in sedimentary rocks in the pore spaces between grains. And so this is where sorting comes into play when you're looking at what percentage of the rocks are pore spaces and what percentage of those pore spaces are connected. So that has to do with your first assignment on groundwater. Groundwater in general can be thought of as being found in different zones. And so this is a really general kind of groundwater layer diagram. So we're going to talk about some of these layers. Basically, you see that the groundwater zones are broken into what's called the zone of aeration and the zone of saturation. In the zone of aeration, this little circle here is enlarged here so that you can see how the sediment is different in the zone of aeration than in the zone of saturation, which is enlarged in this circle down here. The upper limit of the zone of aeration is called the belt of soil moisture, which is where water is held by root action, basically, by root systems. And it is sort of it depends on the environment, how deep the belt of soil moisture is. This diagram, incidentally, will be on your third exam, and you'll be matching up these rock layers to their names. So one of the things you probably notice here is in the zone of aeration, what is different from the zone of saturation is that between grains, there is both air and water. So if you've ever had to turn off like the water in your sink or your toilet to do some maintenance and then you turn it back on, you probably remember the sound. It's pretty distinctive. When you turn the water back on, it makes like this horrible hissing, screeching sound. It's like souls being ripped through PVC pipe. And the reason it sounds like that is because you're not just sucking out water at first. You're actually sucking out both water and air, and the air is what makes that sound. For that reason, you can't pump on a well that is in the zone of aeration. When wells go dry, this is because they are within the zone of aeration and you're just sucking out some of the air between the particles. There's not a ton of water in the zone of aeration. The lower limit of the zone of aeration is called the capillary fringe. There's really nothing that exciting about it other than it marks the bottom of the zone of aeration. The capillary fringe kind of sucks up a little bit of water from the zone of saturation. You can think of it kind of like you have a bucket of water and you have a sponge, a dry sponge, and you just place the dry sponge on the top of the water level in the bucket. And you know that some of that water will be sucked up into the sponge above. It's called capillary action, where water is actually sucked up into something overlying it. So that's what's happening in the capillary fringe. Again, not super important. What is important is that it is just above what's called the water table. The water table is super important. The water table marks the upper limit of the zone of saturation. If you've ever gotten water in your basement, that's because the water table has risen up, and it has risen up above the level of your basement floor. And basically groundwater is rushing in through pore spaces and fractures in the foundation of your house. And the water table will change its depth seasonally. During the winter, generally in the Northeast, it will drop because you have a lot of water that's kept on the surface in the form of snow. And then in the spring, when that snow melts and you have high precipitation events, that water table will rise up. That's when you're more likely to get water in your basement. And it's really because the zone of saturation itself has risen. Water tables will respond to changes in climate, and they will respond also to urbanization. If you have a lot of water that used to go into soils, infiltrate into soils, but instead maybe you pave a bunch of roads, you take out a bunch of trees, and you have a lot of water rushing into a storm sewer system instead, that also will cause the water table to drop because that water gets siphoned elsewhere. So water table is crucially important because anything below it is part of the zone of saturation, which is suitable for pumping on wells. Zones of saturation are characterized in areas where all the pore spaces are full of water and can be used for pumping. So those are the 6 layers that you should know within a groundwater system. There are some locations where the water table, the top of that zone of saturation, will actually intersect the land surface. And those are called springs. If you've ever been kind of hiking in the woods and for no observable reason, you suddenly step in a marshy, swampy area where water seems to be rising to the surface, that's a spring. So a spring, I'm going to show you a picture of a spring here from Acadia National Park. Acadia National Park is on Mountain Desert Island, which is off the coast of Maine. This is a picture of it right here. Basically what happens is that in Acadia National Park, there is, do you see where I stole this image from? There is a layer of granite. Granite is impermeable. That means that water will not percolate down into granite. So what happens there is that any sediment on top will just kind of pool on top of that impermeable rock, and you'll have a water table, and sometimes that water table will intersect the surface, which is where a spring is located. And actually here's a picture of one of our students, and this is where the groundwater table intersected the surface. You can't really see that very well. There's water flowing out of here. I'll show you a really short video. This video is taken in Lake Ontario several years ago, where this is a spring bubbling up to the surface. So this is groundwater, and I feel like I looked upstream here. I'm at a very small beach in Ontario, Canada. So that's where the spring hits the surface, and then it flows downhill as water tends to do. This is all spring water here, and it flows right into Lake Erie, and there's a boat. So that's another example of a spring. Cool. Sometimes springs can form where we have something called a perched water table. So a perched water table when you think of the word perch, you might think of like a bird, and you should. Perched water tables are found where you have an aquitard, a rock layer that doesn't transmit water, most likely because it's impermeable. So here we have a sort of a regular river valley. And during precipitation events, what happens is water percolates down through an aquifer until it reaches the water table, until it reaches the zone of saturation. And so here's your large regional zone of saturation. What's different is that here you have a small clay lens, and a clay or shale is an aquitard. Water can't pass through it, is impermeable. And you can see that clay lens isn't just here, but it kind of exists in 3 dimensions all throughout this valley. So when water rains down here and infiltrates into the soil, it can't drop down and get to the main water table. So instead what it does is it kind of pools on the top of this aquitard, and it perches like a bird does on a stick. So this is a perched water table. And you can see that in some locations, like all throughout this valley, the perched water table intersects the surface here, and that's where springs are forming on the hillside. What that means in a practical sense is that if 2 neighbors in this rural area are both digging for a well, this neighbor can dig a well that's actually deeper than his neighbor and still have that well be unsuccessful. And it's unsuccessful because it doesn't intersect with the zone of saturation. It's still in the zone of aeration. So this is an unsuccessful well, while his neighbor was fortunate enough to live over an aquitard, so that well did intersect with the perched water table. And so because it's within the sort of localized zone of saturation, it is a successful well. One other thing that's useful here is, do you see how the water table drops just a touch around the well? That's actually called the cone of depression. And I used to, when my dog had surgery, I said he was wearing the cone of depression. But really all it's showing you is that they're actually pumping on this well. Because when you pump on the well, the water really close to the well is the first stuff to be sucked in, and that'll draw that water table down just a touch. So springs sometimes can be heated by groundwater, by sources of geothermal heat. And that's when regular springs become what are called hot springs. Hot springs are slightly different from geysers. So for this portion of the lecture, you're going to be looking at some places in Yellowstone National Park. And this is a hot spring. This is called Octopus Spring. This is one of the first times that I thought I was going to see an adult die. So I was on a field course with a whole bunch of other geology professors. Like, they weren't students, they weren't just people, they were geology professors. And this is really acidic water, and it's really hot. The reason why it's hot is because it's in Yellowstone National Park. There's a massive magma chamber below the surface that is heating this water. You can see the steam rising out of it. Some of that is volcanic gas, but some of it is also steam. But just like any other spring, the groundwater table intersects the surface, so it flows right out to the surface here. And one of the things that you probably can see right here is what looks like land, but is in fact not land. So I was there with a microbiologist, and the microbiologist had just finished telling our class that this is actually a bacterial mat. This was really just organisms harvesting sulfur out of the water to create and to reproduce, basically, and undergo chemosynthesis. So at the same time, one of my classmates I saw walking toward the water off of the trail, which was clearly marked to not get off of the trail, with an Aquafina water bottle, and his intention was to get a sample of water that is so acidic that it is comparable in pH to your stomach acid and about 160 degrees Fahrenheit. And he was going to fill the Aquafina water bottle to take a sample. And he was walking right towards one of these bacterial mats. And I was like, wow, this guy could get really hurt or die. And in that moment, I made the decision to just see what happened. Luckily, the microbiologist also saw, and he was not having it and told the guy to stop. It just goes to show you, sometimes it doesn't matter how much education you have and knowledge, there you are. So this is a short video clip showing you not only how close you can get to the hot springs in Yellowstone and still be reasonably safe, but also you can see how much volcanic gas comes out of these. This particular hot spring has a lot of clay coming up as well, so that's why it looks cloudy like this. You can see that the acidic steam here has killed all the grass in the area. And the water is bubbling up partly because of volcanic gases and partly because it isn't completely easily flowing to the surface. So that, oh sweet, is a hot spring. The difference between a hot spring and a geyser is really just the plumbing. So a hot spring is where the water table just intersects the surface. A hot spring is a little bit different, a geyser is a little bit different, and it's because there's a very narrow passageway connecting the groundwater system to the surface. Geysers are regions where groundwater will erupt forcefully from a really narrow connection between subsurface chambers and the surface. And that is illustrated in this diagram where you can see heat coming up from below from cooling magma. So this water ends up being much warmer than the water at the top. So the water at the top is cold and also creates kind of like a cold water cap on the whole chamber. So this chamber partly exists because of acidic groundwater, and it partly exists because of hydrothermal gases that have kind of eaten away at the subsurface. And so it's not like karst topography where you have limestone. This is all volcanic material that this water for the most part is filling. So over time, what happens is that the water at the bottom starts to expand. And when it expands, eventually it will fill the entire chamber. Once it expands to the point where that cold water cap starts to flow out onto the surface, it's kind of like a huge bottle of soda with a lot of dissolved gas, a lot of dissolved carbon dioxide in there. As soon as that cap is taken off, the whole chamber flashes to steam and empties, and the whole process starts over again where groundwater will fill in through these groundwater chambers. What you'll notice is that, so here's the groundwater table, is that this is not a geyser yet, and neither is this one. If the groundwater system rises and the water table gets closer and closer to the surface, this acidic groundwater in the future may eventually crack through and dissolve through the bedrock here to create geysers in the future. And here you can see another groundwater system where it's turned into a geyser. So the fun thing about geysers is that they're very unpredictable. Old Faithful is probably the most famous geyser in the world. That is also found in Yellowstone. Here is a ridiculous video of it that was taken when we first bought a department digital camera back in the day, and didn't quite have the fine points of videotaping things down yet. And this is Professor Barone, who you've heard me talk about a lot. This is Old Faithful erupting, which erupts every 60 to 90 minutes in Yellowstone National Park. It's relatively predictable. There's a countdown clock there. They serve ice cream and they tell you how long till the next eruption. It's actually one of the worst parts for me in Yellowstone, just because it's kind of a tourist attraction and not so much of a national park feel, I guess. So we gathered here. This is all sort of this is called sinter. This is what happens when volcanic rock gets kind of dissolved and then spit back up through the geyser system and redeposited here at the base of the geyser. What you'll see is that there's no trees in this area, and again, that's because the groundwater is acidic and would kill trees. There are some grasses for sure, and so there are geysers that erupt, like Steamboat Geyser in Yellowstone erupts like once every 10 years. You never know when that's going to be. And let's see, there's other geysers like Constant Geyser, which literally erupts constantly. Every single one is different. Every single time I've been there have been children crying by the end because it's just hot in the summer in Wyoming. It gets to be about 100 degrees and kids are miserable at that. And honestly, so are lots of adults. So Yellowstone National Park actually has 2/3 of all the world's geysers and is well known for its hydrothermal features. So these are some pictures of some hot springs. This is also a hot spring. This one is my favorite one. It's called Grand Prismatic Spring. I brought my own kids to Yellowstone once. I brought students to Yellowstone many times. I love it. I'm never really worried about there being a super eruption. Honestly, there's plenty of other things to worry about that are way more likely than super eruptions. It's a fantastic place if you get to go. If you don't like cold, that limits you to like June through September pretty much, but it's fantastic. So this particular hot spring, Grand Prismatic, in addition to having almost no sediment to make it cloudy looking, also has just a wide range of temperatures. It's very acidic, but some of the blue water here, the deepest blue water, that gets to be 170, 180 degrees Fahrenheit, close to the boiling point. And it gets cooler as you move away from the center of the hot spring. This water here is about 120 degrees Fahrenheit, still very acidic. But all of the colors here that you see are the result of bacterial mats. So the Grand Prismatic Spring actually flows down into, this is called the Firehole River in Yellowstone, for obvious reasons. And really only the area right around here is warmed up by this, by the hot spring. It's just fantastic. Yellowstone is also really well known for its wildlife. Oh, here's Old Faithful again. This is, again, Grand Prismatic. This is a really cool spot in Yellowstone where was limestone in the subsurface that was dissolved and then kind of reformed up at the surface of Yellowstone. These are called carbonate terraces. And the orangey green stuff you see, those are bacterial mats too. It's very cool. This was a spot where 2006, I think, where some of the carbonate material actually took over the trail, and this trail has been closed for at least the last 14 years for that reason. There are signs everywhere in Yellowstone about safety. And as you know, people don't always listen to recommendations, but there are signs everywhere about staying on the walkway. That is definitely true in carbonate terraces once they cool. So you can see when they're active, not only is there like actively flowing water here, but you can also see they're kind of lumpy looking, and they have these greenish orange spots where there are bacterial mats. When there's no active water, they become kind of gray, and they're very brittle, and you can fall through them. There's tons of wildlife. This is the most annoying ground squirrel in the world. Ground squirrels in Yellowstone start chirping about 5 a.m. and don't stop till about 10 p.m. And they aggressively want any sort of snacks you're willing to share with them. This is the first time I actually saw black bears. These are black bear cubs climbing around on an old landslide deposit. It's a mama elk and a baby elk, which is really cool. There are herds of elk that migrate between Yellowstone and then down into the Tetons. There are bison, also herds of bison that migrate between Yellowstone and the Tetons. Bison are fantastic. They just walk wherever the heck they want because they're 2,000 pounds, and they're gigantic. And so a lot of times there'll be bison that will just create huge traffic jams in the park. People get very confused by bison, partly because they seem like giant cows and people really, really want to just like hug them. I think that people think if they were that dangerous that we wouldn't be allowed to get near them, but that is not true. In fact, this is one of my favorite videos. I promise no one actually gets hurt in this video of bison in Yellowstone. Bison are humongous. So here's people walking on one of those paths. This man is not on the path, which is not a good idea. But they irritate the crap out of this poor bison, who lets them know that he is mad. So you start to see the bison like stamp his feet and shake his head. And then you see people run, which is really dumb. This poor kid. But my favorite part comes here with this father of the year. Watch his facial expressions while his son almost got trampled by a bison. He thinks it is hilarious. He has no idea that his son was almost just killed there. Bison kill people in the park every year, and it is 99% of the time people's fault. Oops, I want to go forward, but I'm going backwards. Okay. The other huge organism in the park are bears. These are grizzly bears. You can tell they're grizzlies. First of all, grizzly bears are huge, but they always have this hump here. This is a rare sighting in that there were two grizzlies together. Usually they're very solitary animals, but not this time, which was sweet. Barone and I camped with students exactly one time in the park, and we set up our tents one night, and we went to the ranger station just to check in at the campsite, and he said to us, just so you know, there's been like a bear that's been rummaging around campsites, so make sure you sleep with all your stuff in your car and don't leave food out. So we said okay, and we went out, we Yellowstoned it all day, and we got back to the campsite at night and went to buy firewood at the ranger station, and the ranger said, do you remember I told you about that bear? He said, well, he took down an elk in your campsite. And, you know, like, we removed the carcass, so it's fine. And I looked at Professor Barone, and her eyeballs were like the size of saucers. And I was like, well, I don't know, man. Like, she was definitely looking to me for assurance. And I'm the type of person who, when I don't know what to do, I just kind of laugh a little. And I was like, well, at least he's full. Like, I don't know what to tell you. It was the least restful night, perhaps, of my life. But bears are everywhere. Important hints for hiking in bear country is never hike alone. Never be quiet, because you never want to scare a bear. And I always like to say you have to make sure that you hike with someone slower than you, because you cannot outrun a bear, but you can outrun the slowest person. That's a beautiful story. Bears are not the way that most people die in Yellowstone, and neither are hydrothermal features. It is actually bison. This is an actual flyer that you get when you get into the park. That bison or buffalo can weigh 2,000 pounds and sprint 30 miles an hour, 3 times faster than you can run. They may appear tame, but they are wild, unpredictable, and dangerous. And that is absolutely true. Number 2 way people die in the park is by not following warning signs. So this is a great warning sign. It's written in at least 4 languages. And my favorite part of this warning sign, well, certainly there's this part where the kid is just like off the trail and in the hot spring, which is not advisable at all. There was a crazy story 2 years ago where there was a brother and sister, and they were just kind of hiking their way across the country, and they went to get into a hot spring in Yellowstone, and brother leaned down to test the water to see if it was too hot or too acidic, and slipped, and he fell into the hot spring. And then his sister went for help. By the time they got back, the only thing that was left of this young man was like his belt buckle and his wallet. Everything had dissolved. It's crazy. So that's a downer of a story, but look at this sign, because the mother is like, my son, and the father is just walking away, which seems very, very on point. So anyway, that's a little overview of the groundwater system, as well as an overview of springs and hot springs and geysers. All right, time for some karst topography.